Okay then, good afternoon. You will find my presentation will be from different angles, not like you guys just discussed it, but contribute. I think very much contribute to this state sort of low carbon constructions or zero carbon or green buildings. Okay. You can see what I'm going to quick go through is more or less is what we have done in our group. Is more focused on this natural and renewable resources for this building material. And you can see this is very much on this how to look at this program and the transitions from this oil-based economy to this bio-based economies. Okay. I'm not going to give you very sort of technicals. It's quite late this afternoon, and also I'm just going to go through this some of the project. But any of you, if need more information or want to know more about what we have done or what we are doing, and please feel free to get in touch with us. Okay. And later you're also able to see some of our work in laboratory as well. What is the behind this sort of what our research basically from us? I'm more all time working on these materials, especially for the construction industry. And you can see actually in Europe, which we consume huge amounts of this material. And if you look at this, give you some facts, is this about 600 building materials which per head per year, what we are doing. However, and then if you look at that, how does it contribute to this climate change, or we want to look at which material is greener than the others, and then you will be, I can quick go through that. If you look at this mile steels, and you can see what per ton of this material we produce and how much this CO2 it will release. And if we look at cement, and you can see almost 1 ton of this cement it will release to this to the air, which is about 1 ton of CO2 as well. And I look at concrete, of course, depending on what aggregate you use. And then if you look at the plastic, and also depend on what sort of plastic material which we are using. And then also that's very variable. Aluminium, you can see, also have very high, very sort of energy consume product as well. And of course, look at renewable material that we are, especially in UK, I think are doing very well in terms of how to use these renewable materials. And you can see that's because of these negative carbons. Okay, we will expect that negative carbons 1 to 2 tons if you're using 1 ton of this timber product. Okay. However, if I give you the other data, you will be able to see that that is the challenge. That's the reason why we are now so focused on these renewable materials, renewable resources for this building construction. If you look in the last 50 years, what is the population increase? We're talking about 2.3 times increase across globally. And then if you look at what the material use, which increased, you look at cement, which increased 11 times in terms of the consumptions. And then if you look at the steel, which is 4 times, and plastic, 48 times increase in the last 50 years. And then if you look at aluminum, that's about 10 times increase. And you compare to the population, only 2.3 times increase in the last 50 years. And unfortunately, that's for the renewable material, which is a timber product. That's only about 1.6 times increase. That's the reasons I think we need to propose this product. And then if we look at the energy, of course, you all know very well what the energy consumptions is related to the building. that's about 40% of the total energy, which is related to the buildings. Okay, and of course, you all know about how much that the buildings use and where that energy go to. Okay, and this is of course this about heat loss, and of course energy which is actually equivalent to the CO2. Okay, you're using energy and you release the CO2. Right, okay, and of course we all know that the Europeans, which is 2020, you have to be net zeros for all new building constructions, and also you can see what is the target 2020, 2020, and 2050. Right, okay, so. Yeah. No, I know this is for the Europeans. Yeah.
We might not be in Europe.
Yeah, right, okay. Right. And, right, okay. Now, so what we are doing, we're doing from the one project later I'm going to go quickly through is about how we look from Grow2Build. Basically, we look at the whole supply chain. And you can see here, we look at the traditional constructions, and from here, and then we look at what can be done. And then we look at the whole supply chain from grower, from very beginning of this green material or renewable material, and what should be done, not only in terms of this material properties related to the climate, but also this related to the soil fertilizer, how that's different as well. And then go to, this is the whole chain from here to here, and then we can look at, how that should be grown, that can be more, productive, and then finally, we look at where that can be used, and for the building constructions, and you can see all these different material, how this green material can contribute to this low carbon and also global climate change. And this is something, and then we look at that, we've been long time doing all this product, and this just gives you a list, very quick go through, all this material, what we are doing. We started from this material from early about 1997, we tried to look at how, that's the first project we're doing is Technology Foresight Challenge. At that time, we tried to look at this, how this renewable or non-food crop, which can be used for this sort of a different type sort of material. And I quick go through this, what we do. We look at this process, how to convert this basic, I think most of you already know, for this plant material, basically three components, cellulose, hemicellulose, and lignin. That's all actually this material, which you go to the very down to the unit, which is the glucose, and how you convert that to the fiber, to that glucose, and to the energy, and or to this polymer product, which timber itself is a polymer product, of course. Okay, and then look, of course, this is a plant that we look at the fibers, and we look this composite, all different materials for manufacturing, transportation, constructions, and even the defense, because one of the very interesting, which is impact resistance, which is very good as well. And of course, look at this polymer and coating, etc. And then we also look at this for the fiber material, of course, for textile, and textile, of course, convert to this material, a construction material as well. And then we look at, and then of course the other project I quick go through, and then later we have this panel product we call the panel product. That's basically we look at current existing sort of product like a wood-based panel, which is mainly from timber-based at that time, about 2000, and we look at how to enhance. That time we already realized this material should be promoted And you can see, look how efficient, competitive for the construction use at that time. Look at all sort of material under different stress mode and different applications for whole construction, flooring, roofing, or these wall panels or column or beam. That all need to be done. And especially look at the whole harmonized European construction and European code and standards. And then we have NetCont, which is a more UK-based project. This time we look at more non-food plant-based or bioproduct from agriculture, and we look at all these high-strength natural fiber composite productions. And then we also look at cellulosic materials for different resources, for example, for the paper sludge or from domestic waste. All that's a fiber material can be used, can be extracted from there for more value-added production. And this is also UK project as well. And then 2011, and then we're coming back to look more. This time we try to introduce very high technologies into this very traditional product, traditional material, which is timber, which is very traditional material. And then we have new product, which is nanotechnologies. And then you can see this is nanotechnologies, which one of nano is nanocellulose, which is nano itself from this renewable material, i.e. nanocellulose from timber itself, and then how go back to serve for the timber product, because the timber have some of that inherent defects, and that defect need to be changed or to be modified using nanotechnology. And this is a European project. And then we have a look at coming back at all this is previous this project is more look at the structure applications or material as structures for the building use. And then we look at more energies. And then you can see this is ice clays. And then we look at this natural material or this renewable material, how that can be made to very high requirements or demanding for the insulation use, especially for this building, which is since 2013. And this is the European project. We look at this aerogel product, ice cream aerogel, and for the construction use. And then we have VIP as well, and that's Maria here, which is our evaluators. And we look, this is sort of also using natural materials and how to get this to make us in a vacuum insulation panel. Vacuum insulation panel, most of you probably know, based on a silicon film. And we are here using naturals or renewable material to make that as a very super insulated performance for that building application. And then another project, which later you can see our laboratory, we call Grow2Build. What we have developed all sort of this product, and now we need to see how industry takes this idea, our idea, and then the concept of product to for the real life. Okay, this is the Grow2Build project, and I'm going to give you a few more slides. You can see what we have done. You can see this basically, we now have a lot of development, and we now want to look at where is the bottleneck, why this current is still not being extended use. And that's why we find out, identify the bottleneck, and then resolving these problems. And then also, because we work as Europe, we try to look at where identify the different expertise and different expertise in terms of the technology, but also in terms of this is the venue where this material probably have been developed, which will just help for the industry. If they need a technology, they know where to go. They need product, they know where to go. Build this European sort of roadmap, and then basically serve, promote these applications. And then one of that's interesting, which is pilot. You can see when we find these problems, when we find these bottlenecks, and then we need to resolve that. Because of course, especially this new product, and we all know that construction industry is very, very conservative. It will be very, very difficult to introduce. You got new idea or new product to be used, or especially commercially extensively used, and there always need to be done. Okay, so when we find this thing and we compare to the traditional product, and if we find something which need to be done, and that is a pilot. So we set up the different pilot across Europe. And for example, one of these is look at these fire reactions. People think using this natural material, first they will think how good there's a fire resistance, especially for construction industry. Anything you turning about this natural thing or fiber thing, they will ask how about this fire performance. So we do this pilot and develop this to work with industries and develop this and produce this fact sheet, and then people can look at that and can convince this industry, say, oh yes, they can use it or not. And also this is for wood applications, for the coating, biocoatings, and then for the infrastructures, also pilot biocomposite and fiber reinforced composite, of course also for axial composite. And then the more pilots, for example, this is doing the block as well as do any sort of the technology needed. And this also cheaper product like a conventional wood-based panels, and then the insulation product as well. And so that is a pilot, and develop a lot of database for industry to use. And then we also set up a center of excellence, European Center of Excellence, based in our laboratory. Later, my colleague will take you there to have a look at it. That's basically created a venues which is industry or manufacturers or construction industry. If they want new product, they want to know more about how that can be used, or what technology, if I produce raw material, what technology can be used to convert this raw material as a construction product, and then they know where to ask. Okay, so that is basically, later you can see. And just have a quick go through those sort of product you can see later, and some of the product just displayed here. I just go to very quick go through that. And then later you can see that this is all product in our centers. You can touch it, you can feel it, and all this insulation, but just very quick, all different material. Now, what I'm going to look at, because some of you maybe later not go to the center, so I just go through that very videos.
We have established the European Centre of Excellence here at Brunel University, London, as part of the Grow2Build project, which is funded by the European Regional Development Fund. Grow2Build works on the transition of the Northwest European economy from an oil-based towards a bio-based economy. Specific focus is put on the integration of local, sustainable cultivation of resources in this future-oriented economy. This centre has been created in order to give stakeholders permanent and direct access to all information developed. In the Centre of Excellence, an exposition has been set up based on innovation in manufacturing of bio-based eco-building materials such as hemp and flax. Experts will be available to inform stakeholders on technical matters of product manufacturing. Manufacturers can approach the Centre of Excellence with their technical questions and requests for product innovation. This centre will become the focal point for technical consultancy and dissemination of technical information to the building industry, providing the physical evidence of eco-building materials for training and study exchange. The centre at Brunel University London guarantees the continuation of the initiative after the project. This centre can be seen as a platform where demonstration, guidance and education on bio-based materials such as hemp and flax is permanently available with the manufacturers as the main target group of the center.
Okay then, thank you very much.